So derivatives are differentiable where they are smooth and continuous, and where the derivative is defined. Okay, so where we have a kink in the graph, okay, or a bend in the graph, that is a non-differentiable point. So at x equals 1, x equals -1 is not differentiable, okay, because of the kink. Here, the function is, the limit is kind of at a kink, but that's not why it's not differentiable. It's because it's not defined at x equals 2. Okay, so at x equals 2, it's not differentiable. At x equals -2, it is discontinuous. Okay, so at x equals 2 and -2, it's discontinuous. There's a hole there. It's not defined. Okay, it's discontinuous here. Okay, so it is not differentiable because of discontinuity. And the last thing that we have to be careful is this vertical tangent line. Okay, so the derivative is not defined at that point. Okay, so it's not differentiable where the derivative is not defined. So at x equals 0, it's not differentiable because of that vertical tangent line. So here again, the discontinuity at x equals -1. Sorry, x equals -2. There's a discontinuity there, so it's not differentiable. We should probably also back up a little bit and state that the endpoints are not differentiable. So x is not differentiable at x equals -3. This is an endpoint. Okay, so an endpoint is not differentiable. Okay, this is discontinuous. Okay, here there's a kink in the graph at x equals 1. Okay, so there's an abrupt change in the slope. Okay, so it's not differentiable at that point. And at x equals 3, we cannot differentiate endpoints. When we are matching the derivatives with their original functions, so on the right hand side we have derivatives, on the left hand side we have the original functions. One of the keys we want to look for is we want to look for zeros in the derivative. Okay, that's one of our main keys. We look for the zero in the derivative, and we see that the zero relates to a horizontal tangent line there. Okay, so we should also check a few other things. So the other things that we can check for are the positivity of the slope. Okay, it is all positive in this region here, and on this side it's all negative. Okay, it's all negative slope. The other thing is there's an abrupt change in the slope at this point. Okay, there's a kink in the graph, and here notice that there's an abrupt change in the slope. Okay, it's going steep and then less steep abruptly. Okay, and then there's a constant slope. So we have a constant slope here, and again there's a horizontal line on the slope line. So those are some features that we can look for. So again, we're looking for zero slope. We're looking for positivity and negativity of slope. Now we can see that they're, in this case, check for abrupt changes in the slope, where the slope just jumps. We can look for constant slope parts, so here and here. So those are pieces that we can look for. Okay, so by default then we know that these two go together. But why do they? Let's check. Okay, so here we have increasing slope. So slope is increasing. Sorry, the slope is decreasing. So we have large slope. Okay, and then we have low slope. It's all positive. This is all positive. And we have a large y value here, which indicates large slope. Okay, up here. And here we have low slope. That means low y coordinate, which means low slope. So it's getting close to 0. And we can see that it's approaching 0 slope. It's approaching a horizontal tangent line. Okay, so there's some features that we can look for those. And we can connect those two together as the derivative and its original function.